in this complex design of the GPU or AI LM, we should not assume anything.
Earlier, the data centers were building like 15 megawatt per building or 20 megawatt maximum. But now, after this AI and ML workloads, the buildings start getting more efficiencies. We are now building one building or one entire envelope with somewhere 40 to 50 megawatt per building, even more.
I want to know from you, how bullish are you on liquid cooling? You're watching W.Media Deep Dive, our exclusive video podcast series examining the cloud and data center industry across South Asia and the Middle East. And today we are discussing a very exciting topic: building tomorrow's infrastructure, data center design and delivery in the age of AI. And today we have some very special guests joining us: Mr. Sanjay Kuntal, Senior Vice President, Data Center Projects, Yotta Data Services, and Mr. Mahendra Choubey, ABP Project and Delivery, STT GDC India. Welcome to the show, gentlemen.
Thank you.
Thank you, Deborah.
Let's begin by you telling us a little bit about your professional journey so far and a little bit about your organization.
So I am working for the data center since last 15 years. So I did multiple data centers for HPC, and now we are doing this GPU data centers and colo data centers. So this journey is long, but now in this GPU drive, we are really enjoying this engineering and passion of the data center.
Okay. And how about you, Mahendra?
So Deborah, I'll just take a quick brief of my professional run through as on today. So I'm currently working with STT as an AVP projects and delivery, and leading the entire design, delivery, and construction programs for STT for all the regions in India. And my journey so far, I've been working in data center, or I can say pre-data center, which is the telecom environment, for last 18 years. And so I have been working from 1 megawatt to 100 plus megawatts of campuses in my entire life cycle of my career. And in last decade, I've worked with companies like AWS and Microsoft in past, and lead the hyperscale builds and the new region strategy in India. And globally also, I worked in Americas and delivered the same capacities back then. So having said that, I am having the experiences from hyperscale build as well as the co-location build and the edge data center, which is the small scale builds per se, and having an exposure on the co-location environment, which is my major forte as part of delivery. So that is what my overall portfolio is and what I have been delivering. So I can say as on 2025, I have delivered or conceptualized around 700 megawatt of campuses across the globe, and delivered and commissioned 270 plus megawatt of capacity to enterprise and the large scale customers.
Let's jump right into segment one, that is the impact of artificial intelligence on data center design and management. My first question is, how are AI workloads, which involve training large language models, changing data center design and architecture?
First of all, that when AI come in the picture, earlier traditional data centers was around 10 kilowatt per rack. Now, because of AI, it is going up to 50, 60 kilowatt per rack. And in the future, it may go up to 200 kilowatt per rack. So a lot of challenges here for the power distribution system, cooling, floor loading on the building, and architecture. Earlier rack was small, now we need more space for the racks. Network architecture, because of this LLM, we need low latency network between the servers. So all the network architecture and all need to be upgraded to meet the requirement of GPU.
Mahendra, how about you? What have you noticed?
So Deborah, this question is pretty exciting, I can say. So if we see future of AI and the ML workloads in next 5 to 7 years horizon and beyond. But before delving deep dive into this, we have to see how we have come to this stage. So currently we are designing and delivering the traditional builds, and the journey so far is we have started from 2 kilowatt, 5 kilowatt per rack to 10 kilowatt, and now we are somewhere in the middle of 10 to 20 kilowatt per rack. Okay, with air cooled system and the power distribution system. There are multiple layers of n plus 1 to n plus 2c, n plus n. There are multiple topologies are there. But how we are progressing further when the AI workloads or the machine learning or LLM modules are there. So the capacities or the rack capacities or rack densities are increasing so drastic, like increasing from 20 kilowatt to 60 kilowatt or 100 kilowatt and beyond. Then it is a 200% jump on the capacities. At the same time, managing power into the overall design architecture is very complex.
I'm going to come to that a little later in this discussion because that is a subject unto itself. But first, I want to talk about this high density computing that you just brought up. You're talking about GPUs and TPUs. What role are they playing in driving new design paradigms?
So yeah, so when you master plan or when you design any campus or any capacity, so we have to see multiple facets of it. First of all, how many megawatt of design we are building as a campus? What is the overall density of the each rack? What is the floor loading? Because Kuntal sir has rightly said the floor loading has increased like anything. Because when we are increasing the size of the rack, when we are increasing the compute, then the floor loading also increases, and the rack capacities and the rack densities increase, and then the floor loading also gets impacted. At the same time, power demand is increasing multifold. That is another criteria. And not only that, the construction methodologies involvement or the incorporation of the new technologies like prefab or PEB structures and the mix of structure of both, these are getting too much attention right now, and we have already started using it. So those are the areas which are getting introduced into the design. And not only that, what I see as an more involvement from design and delivery perspective, because data center is a very complex machinery as an entire system, where we need to have a very detailed planning much before the delivery started. So the planning and the design piece has become more crucial and critical along with the project management. That is where it becomes one of the most pillar or most important pillar of the delivery, because once my planning is completely done with 100% accuracy, then I can do the complete program with my schedule, with my cost, with my quality, with the safety, and I can deliver it better. So that is the main pillar I can say. And then it comes to how the resource planning, how the skill set of the people are there, because traditional data centers have been done by multiple skill sets from MEPF and civil and structural architecture teams. But now we also need to see how the new cooling environments are coming, how the CDUs are getting introduced into the direct immersion cooling. So those kind of technologies we also need to have considered into the design, and then we need those kind of skill sets, not only at the regional level but at the SME level, so that we can do it right and we can match the requirement of the customer and we can deliver.
I'm glad you brought that up, and we'll delve into that a little bit more in our third segment. But let me now ask Sanjay, what are your inputs on this? All this high density computing, how is it making you think differently, even from the conception stage?
Yes. So Mahendra is rightly mentioned that this driving factor of the GPU is the load. Basically, this power density is driving that and changing the model of NVIDIA servers and GPUs. Even though every quarter we get new model launched. So main is the power density. Power density is too heavy. As of now, we are going up to 60 kilowatt per rack, and future we are going to 200 kilowatt per rack.
I was going to
This
come
is-
to that, because you have to innovate to tackle power distribution when it comes to energy management for high density racks. So, how are you tackling that?
Yeah, I'm coming to that point. So it is very difficult to handle this kind of situation. First is the power management. These all the GPU have a trends of sub-synchronized oscillations. That power oscillations is like anything. And when we are going for the AI factory, when we have 20 megawatt or 30 megawatt GPUs load in any data center, these oscillations will affect all the power equipments, distribution system, and if these all the sub-synchronized oscillations will synchronize, create a resonance, and that will lead to disconnect power from grid. This is a major problem in the GPU load. For now, coming to that point, how to tackle this kind of challenges. So in the power, we are creating some dummy loads in the programming of GPUs. When one program is going to finish, that dummy program will come in the picture that will stop sudden drop of the load or oscillations. Parallelly, earlier we are going for the K4 transformers for the isolation. So now we are going for K13 or above because of these oscillations. So in the power, this oscillations is going to kill lot of distribution, and we have to upgrade that to make it compatible with the GPU load or LLM AI load. This is for the power. And one more challenge in the designs. Earlier we have H100. H100 was that in the distribution system. I'm coming to that point. H100 have 4+2 power supplies, 4 working, 2 standby.
Okay.
In the traditional data centers, we are planning N+N. But this kind of load, we have to go for 2 stream of UPS should be working and third should be standby. So we have to plan for 3 stream of the UPS for H100. Next model, B200. This have 4 working, 2 standby. Now we must have 4 or 5 GPU, rack PDU in the rack. And similarly, that power distribution backend UPS stream should be like that only. N+1 is not going to work in the GPU load. So these are the power related challenge. And in this complex design of the GPU or AI LM, we should not assume anything. In earlier traditional data centers, we just assume 10 kilowatt rack will be come in this data center. We will provide 2 sockets from one A source and another socket from B source. That will work.
It's become more unpredictable now, right? It's become more unpredictable now.
Yes.
I want to go to Mahendra now. Mahendra, you want to also making a point about power distribution. Why don't you tell us what you are facing and how you are facing these challenges?
I will definitely come to that point, but I will again just reach to the same point which Mr. Kuntal just raised. So he raised very good point here, that assumption on the prerequisites of any data center design. So he rightly pointed that there were assumptions earlier that we need to have 10 kilowatt of per rack. We can have 2+2 sockets maybe planned as per the design. We can have X capacity, X number of racks coming into the one hall or one pod. And those were the assumptions. And according to that load, we used to calculate the theoretical load of the entire building in terms of the electrical or mechanical and the cooling. But now, when it comes to the AI capacities or all the GPUs, so that has become so complex right now that we need to have a very realistic load calculations, where we have to have a very realistic architectural design from electrical infrastructure, as well as cooling also we have to have a very clearly defined, because that is not a theoretical based numbers. It's completely on the load driven design. So that is very good point, I can say, and that is just a start. But the more we are dive into the new designs and the new capacities and new type of GPUs, definitely it is going to be more realistic. And AI itself is going to monitor and ensure that those kind of design, those kind of execution strategies and the monitoring strategies will be more precise going forward, maybe down the line years. And I think so that's a very good point. And when to answer your questions, you're right that to tackle the power distribution, we have to have, because we have to have the complete power source strategy for the entire campus to tackle the high density racks and high density loads in each building. So if you see the trend, earlier the data centers were building like 15 megawatt per building or 20 megawatt maximum, but now after this AI and ML workloads, the buildings start getting more efficiencies. We are now building one building of one entire envelope with somewhere 40 to 50 megawatt per building, even more. And in India region, we have started doing that. And with that high density workloads, we are also started using the more efficiency in the design in terms of the usage effectiveness, in terms of the PUE, in terms of the water usage. So those are the areas are getting more efficient, and with high density racks are coming in, we are increasing the rack size deployment and the usage of the entire pod with more effective way. And these are the different factors along the side of energy. And when it comes to the energy, we have to have a very clear visibility or strategy on long term plan, how our entire campus strategy is driven, how the back end HV side substation or the feeders are going to design, how the 220 kV or the substation feeders are designed, how my LILO strategy or how the substation going to be sanctioned for the entire campus. Those kind of strategies need to be designed as per the workloads, and that has been definitely driven in a very good way. Like in India currently, we have a very good edge that we have a power available in multiple regions, but that is a crunch right now in other markets. They have no clarity on the power design. They have a complete exhaustive situation on the power availability, and that is what the red flag we have. Why can't we take those inputs and the learnings and we can implement and augment our system, like, and we can get the power ready infrastructure so that we can get the demand in the Indian or Southeast Asia region. And I think so that is where what Mr. Kuntal has just pointed, how precise we can design and drive, and we can have a clear long-term detailing done, and that's where we can definitely have those high-level business level requirement done and ready at the first stage, so that we can conceptualize and make sure that those capacities are delivered to the customer.
Mahendra, during what you were saying just now, there's something that stood out for me, and that was increasing efficiency and optimizing your resources. And you are using AI within the data center itself to do that, to optimize your resources. I'm actually now more interested, in finding out how exactly are you using AI for things like predictive maintenance, for workload optimization, and increasing your energy efficiency.
So Deborah, that's a very future-focused point as a question, I can say. We haven't seen too much of improvement or work on this part right now in data center environment, but yes, we are seeing it, specifically predictive maintenance, not very vast, but that has started pick up, and then teams are, or operational teams are using all the predictive maintenance strategies for the 52-week schedule against all the PPM of the each equipment, and they are already having the complete record of the past maintenances and having the clear predictive analysis of each equipment against how much those equipment have been used, what are the number of hours they have been using, and those kind of data analytics on the equipment that they are doing, and that is where those predictive maintenance calculations are being done. But I can push one point on the construction strategies. Like we are into the construction piece, so now we have been using BIM, which is a design tools for us. So we have been using BIM, LOD 300, 350, 400, and LOD 500 also. So that has been a complete visibility of design what we have been doing in 2D, and now we have a clear visibility into the 3D and beyond. We also have a 4D design capabilities with LOD 500, and we can do the as-built level. But there are good innovations coming in this aspects, wherein tools are getting more advanced, tools are getting more intelligent. When there are clashes into the design, and with AI itself within the system, within the tool, we can identify those clashes much before when we have actually completed the design. And those kind of new innovations or new intelligence aspects can definitely drive the designs in more precise way, ensure there are no clashes, there are no obstacles, and the detail of the scope will be completely clear at the first place, so that we don't have a more change management during the course of the construction, and more on the scope change until there is a scope change. So those kind of innovations are definitely driving, and those are using into the data center tools itself. And I can also touch base on the project management perspective. So there are project management tools like scheduling and Primavera and Microsoft Project. Microsoft Project has already inbuilt their own chat GPT and different models into it, so that we can have a more technological predictive scheduling, and we can have a clear dashboard and all the reporting mechanisms and those kind of things being in place without doing too much of hassle. Those are the areas which are started using it, but definitely I can say it's a world of infinity, and definitely this is the area which can have so many opportunities down the line in future. I can definitely hear from
Sanjay,
sir on his views about.
yeah.
Mahendra is rightly said that when new technology come, that is pushing other technologies to come along with. So when this GPU coming in picture, first we change the distribution of the power. Now in the one pod, earlier we are planning 1 megawatt, it is going to 5-6 megawatt. Earlier, if any cooling system fail, so we have a headroom for 5 minutes to response. But when we have 5 megawatt load in the same pod, we have hardly few seconds to respond on that. Otherwise, data center will convert into a fireball. So autonomous response is mandatory for this kind of high dense environment. Okay, so now considering this AI load, so development is started in the power distribution system. Earlier that panels are traditional. Now we are installing sensors in all the electrical panels to give temperature of the bus bars, and predictive and preventive maintenance can be done through AI. Otherwise, temperature will rise and it will blow up. And similarly, for the UPS and other equipments are coming now, technology is evolving like that. It is coming for faster response, and it can be integrated with the intelligent building management system, so autonomous response can be ensured. I said that if 1 minute cooling is off for a 5 megawatt data center hall, so autonomous response is required. We cannot wait for human intervention to come and rectify this. Either we have to switch off the servers, or we have to rectify the cooling problem. So now, before going this kind of high density, Mahendraji mentioned that BIM model. BIM model is one. Another is CFD analysis. CFD analysis, before putting that design into the execution, we have to ensure that our design is going to perform through AI. We will do CFD analysis of all the things. So these all the factors are coming into design now, considering this high demand load in the access control, CCTV, and BMS system. These all are being integrated with the one system. For the autonomous response, lot of algorithm being planned for preventive maintenance, predictive maintenance, and acting very fast. So these are things are required. So these GPUs are driving design of the data center to come along with the high dense data centers and use AI.
Excellent. Now let's move on to the second segment, which is innovations in construction and delivery. My first question is, does the idea of prefab excite you? And do you see an increased interest in modular data centers going forward?
It is really excite, or that is we are bound to do that. I'm in the delivery team. When data center project is initiated, all the time management is giving whatever required time for the construction, they are giving less of. That's it. We need 2 years. They will give you 15 month or 18 month. So it is bound us to go for the prefab applications. Here again, AI is helping us. So we design entire building in the prefab structure. All the elements, we break all the elements, columns, beams, sub beams, in the and do all the start calculations. This structure is going to take this much load or not, and after these all the calculations, we get that everything fabricated outside and bring on that location, assemble it. So it is bound us to do this because of the timelines, and it is very fast to execute.
You are 100% right on the point that from the delivery teams, we have this one of the most exciting areas to look at it. And I can also touch base on the prefab and the PEB structure both. So Mr. Kuntal has pointed rightly, it is a very fast delivery solution in terms of the achieving the timeline and the schedule, because we have seen the clear shift that every customer wants the data center in 15 or 18 months. And whenever we are conceptualizing the new capacities or new DC, we have to have a complete 24 months or 20 months of the entire schedule, which includes my statutory planning and the permitting and all those design piece, and the construction start from excavation till the entire delivery of the floors, including fit out. So it becomes too complex, and there are multiple layers of it. And to manage those timelines and the schedule into the entire program, we have to look at the new way of doing it. And prefab is definitely one of the area which is definitely exciting, along with the PEB structure also. So I can touch with prefab. So Kuntal sir has mentioned right that it is a complete solution where we can do the entire columns design and the beam design and entire prefab slab and walls. So those kind of things can be prefabricated outside the premises in the factory or in the any workspace of the any partner, and we can get it on the site and then install, and then we can complete the finish. But it has one layer behind. I can touch base. For any these kind of solutions, we have to look at how I'm again insisting or pushing on the planning piece, because these are the innovations where we are just connecting all the dots together, all the pillars and the slab and the beams and walls together. But to make sure those fit on right, we have to have a very detailed planning. We have to have a very detailed, precise, joint by joint calculation, strengthening calculation, and every section of the building is completely pre-designed, and those design timelines has to be given to our designers, whether those are internal teams or the consultants, because that is the time. If we do design right, again I'm pushing more on it, if we do design right, then we can give the manufacturing clearance to the right partner, we can do the prefab structure casted rightly without any errors, and we can get the right piece on the side and we can install it. And that is where those designing calculations and the timeline comes in picture, that it's kind of a making sure that every puzzle we got it and we have just scrambled it right, and we have pulled it right piece at the right time. And that is what this prefab is. We have to have a clear design understanding at day one, so that we can get the right piece, install it, do it, finish it, and deliver it. And that is what it happens. And once my floor is ready, then I can give a clearance to my fit out teams or the MEP teams to do the entire base build and the low side infrastructure, so that my entire capacity is ready. But there are multiple pieces of it in terms of civil, how the finishing schedule is, how the core cut is being done. There are so many calculations, there are so many nitty-gritties into it, which needs to considered at day one, which are deliberately or which are somewhere missing in cast in situ design with design and build strategies or the package design. But this is a good way to look at it, and definitely these are the areas where if we have designed right, we can do it much efficiently. And I can say it is going to be a future, and it is future. Along with the PEB is also amazing solution, which has already been used in multiple data centers across Southeast Asia, India region also. And definitely it's already too much popular in the other part of the world. And we are anyways going to adopt it. And it's definitely exciting.
Simply for the PEB or prefab, precise engineering and planning is required, as Mahendraji rightly mentioned that, and that is being can be done through using some softwares like BIM model, STARD, and other softwares doing this all the calculations. So precise engineering is required. One mistake will derail entire project.
Correct.
So here, engineering will take a serious role into the PEB. And now in India, we have capabilities. So this is really exciting.
And I can touch base one more thing. So Deborah, you might see the classic development or the difference between the western part of the developments, wherein India region or the Southeast Asia is a little different, because in western part we see the single story large campuses coming in as a horizontal build. But in India region, majority we are building vertically high, maybe G+4, G+5, G+7. So that is what I'm saying. In our making sure the efficiencies are right, we have to go vertical. And while doing vertical, we have to have those engineering precision at most. And that is a big priority right now, because there are so many utilities, there are so many cables, bus ducts, and electrical utilities coming in from the shafts. There are so many cutouts, so many entries and laying to the data halls in the electrical rooms. So those utilities has to be planned rightly, and that is where the precision engineering comes in. So that is where these are the areas definitely have improvement caution into it. But definitely, like Mr. Kuntal mentioned, we have the capabilities, we have the right partners, we have the right design consultants who are doing it, and they have doing it. So we are on the right path, I guess.
Excellent, gentlemen. But now I'd like to pick your brain on integrated delivery models. Do you see design, build, and operate becoming popular in India?
So I can take a small input here. Design, build, and delivery is definitely a very, very interesting model. But we have to see one step back here. So design, build, and delivery is kind of a hybrid builds, where I have designed it, I have built it, and I am only operating it. Okay. We have to see from the two-way perspective, whether we are doing as a co-location, or are you questioning, or are you pointing out that whether customers can take it from our side. So we have to see in two-way aspects. So I want to have a clarity what sort of which part of question you are questioning on this, from co-location perspective or hyperscale.
Let's look at both, considering you have expertise across both of them, right?
So see, in co-location, definitely it's a design, build, and operate is definitely a popular model. It's not a question. We are doing it. We are designing ourselves. We are building ourselves. We have a a complete set of capabilities, internal SMEs, and the structural or the electrical, mechanical, and all the SMEs are there from design and execution point of view. And from operation also, we have a very a large fleet of data center operations team who are operating entire data centers with their own hands. And I can tell you right now, in India itself, if I can talk about my own organization, we are managing the data center operation for last almost a decade. So it's a very popular model, but there are different aspects to it. There are different models like hybrid builds, wherein as an developer we design, we build, but customer operates. There are so many caution of usage of this model, but yes, design, build, and operate is a definitely popular model in my way.
As Mahendra rightly mentioned that design and build have various benefits like single point of contact. So we don't need to engage multiple vendors and coordinate with them. Streamline delivery, because we have single point of contact. He's supposed to design and deliver, so delivery can be easy. There are some cost savings also, and quality will definitely improve. Apart from this, when we are going for DBO, other factors to decide, do we have our own engineering team or execution team, then we should not go for the design and build. If we are just making a data center and going to operate, so we should go for the DBO. But what are the things which we should keep in mind? One is the contractual complicity. What contract we are signing, that has to be properly defined, and all the risk management has to be considered in the contract. And we should give this kind of DBO when we are finding a partner. We should have a long-term partner. It should not be just he will design and build and went away. He have to take responsibility for the life cycle of the data center we are designing and building. And he should be responsible for the capex, even though whatever committed for the operations OPEX, what POE he is committing, what response time and this SLA he is committing during the contract, that all the things come in the long-term relationship, and long-term relationship will drive this model very good way.
So Deborah, I
see.
can touch base one very, very good point Mr. Kuntal has just mentioned or pointed, the quality piece. So in design and build, if I can talk about from the delivery perspective, so design and build contractually is a very good model, but due to lack of scope clarity, due to lack of what as an end goal my project has, what scope each package will have, what is my end specifications are, what is my entire finishing schedule is. I can only touch base on design and build right now. So he pointed very clear point from contractually, because of unclear gray areas into the scope, it can backfire the entire strategy. And against the unclear scope, the contractor or the partner, whomsoever who's building, that can be a very, very difficult situation for the customer, that my program or my project will not be delivered as what it was anticipated or planned. It was not delivered as per the finishing plan, what we have actually envisaged. And the finishing and the quality, if that is not set right in the contractual, then it will not be delivered and it will not be seen on the delivery. So that is the gray area in the design and build strategy, is that if we need to have a very performing and efficient delivery, we have to have a very clear scope defined in the contractual phase. We have to have a very, very clear a review mechanism or the peer review mechanism, and the review on the each phase of the completion of my design, each phase of completion of my build, so that we can have and we can revisit if there are any miss or lapses from the partner perspective, because these are the areas which can definitely impact. Ultimately, design and build is a contractual model which can have a less risk to the customer, but it become more situational risk if the initial things are not set right.
So there's a lot of thought that has to go in at the very beginning. Yes, Sanjay sir, please continue.
So that it is for the conclusion of this, we should that this is a good model, but it should be contractually bound properly, and all the things, whatever in the scope, should be defined and written properly and should be agreed. And when we are selecting a partner for design and build, that should be a long-term partner. So small issues should not come into the picture and create bigger issues. So that is my advice. This is a good model, and it is quite attractive. As I mentioned, that it will give some cost savings, quality improvement, and SPOC, hassle-free delivery. Single point of contact we will get, and we will get it delivered.
I'm glad you said hassle-free delivery, because I'm not sure if there is any such thing as a hassle-free delivery, given the geopolitical tensions, their supply chain issues. Those are bound to affect your delivery timelines, aren't they? How worried are you about that?
So now you know that how that world is going now. Tariff war, you understand. So we have war situation in the entire world. So this is impacting supply chain management, and a lot of countries or suppliers are not certain because of this tariff war and all. So it is really challenging now. Global supply chain management, lot of uncertainties, and lead time of the equipments is getting increased, and logistic challenges because of this war situations. So delivery time is getting affected, and that is impacting all the projects.
I see. How about you, Mahendra? What are your observations?
No, Mr. Kuntal has pointed right here. So geopolitical tensions when it comes to the tariff war, or when it comes to the regional wars, or tensions between the Middle East area, or into the international seas. So if you see the supply chain or international supply chain, when we talk about from data center perspective, so majority of chiller systems, majority of my high-end UPS systems, or the different components or the cooling systems comes from the imports, and usual route is sea. And not only that, the customers, whether they are importing the racks or their components, it is a sea route. So if the supply chain ecosystem is impacted because of this uncertain times, and then definitely there are lead times to it, there are timeline impacts in terms of the logistical supply, and there are risks, and definitely those are not a situation which any industry is keen to look at it, and we have to avoid those areas. And that is where we have to see, like, what India is currently driving, and made in India or make in India. So I think so that is a very good factor, that we should have everything in control, or maybe all the logistic piece we can simplify. And if we can have those equipments already domestically supplied, then definitely those ecosystem or those supply chain issues can be effectively resolved. And I think so that is the area where we should look at it. And I'm sure that is the point definitely going to come, maybe not very late, but very soon we'll see those kind of developments coming in.
So Atmanirbhar Bharat is the solution to all these challenges posed by tariffs and torpedoes and terrorism that seem to have an impact on the digital infrastructure industry. We need to become self-reliant. We need to become Atmanirbhar.
Yes.
100%.
Okay. All right. Now let's move on to the third segment, which is something I'm very, very passionate about, and that's sustainability challenges and solutions. I want to know from you, gentlemen, how are you aligning with your goals, busily adopting or even switching completely to renewable energy sources?
So So
Yeah,
renewable energy source, if I can pitch in here, so that is not a industry specific or the regional specific. It's a global need right now, and every industry, every organization in the world has their own targets to be a carbon free. So there are timelines. Somebody is targeting 2030, somebody targeting 2040. So there are timelines to it. But definitely, if we talk about data centers, definitely we are high power consuming industry. And we have seen a very, very drastic and very positive trend adapting the renewable energy sources. And there are many solar parks or solar plants are getting installed in every part of the Indian region, with big conglomerates coming in with the new parks and new capacities coming in. There are new investment funds are also taking their steps into the renewable energy from global west, and definitely it is good steps to get the renewable energy sources ready for these kind of demands. And we have seen good amount of power purchase agreements happening on this part. So I think so renewable energy strategy aligning with data centers, and not only data centers, in every industry, has to be a very good step, and definitely it's a positive step for the industry.
Sanjay, so Yotta also has a huge go green policy, and you have been walking the talk on this for a while. Why don't you take us to how you have laid out a roadmap for your renewable energy goals? How do you plan to achieve?
specifically for the Yotta, we have our solar parks, and we have a distribution license within the Yotta. So we are getting power from our solar parks and feeding to our data centers uh, through open access, and being a distribution licensee. So we are using that. But government is also doing a lot of incentivize data centers, and creating a green grid, and that is going very crazy, and goal is set. And apart from this, now data center player is also started increasing efficiency. That is again a green initiatives. So as of now, most of the data centers, when you have colo or you have hyperscalers, even customer is also asking how much green energy you are buying for this data center. So this is going good. Apart from this, when we are going for the bigger data centers or AI factories, earlier we will have that gen sets, which is running on the LDO or fuel diesel. Now most of the designers or data center players are started thinking on that alternative fuels like hydrogen, and other aspects, how to avoid this diesel consumption or biofuel, this uh, carbon reduce the carbon footprint. So even a small atomic reactor people are planning. They have 10, 20, 30 megawatt. They are planning to buy small atomic reactors, so they can avoid other using of the diesel as a fuel. So these things are going on, and as Menderji rightly mentioned that we have a target, and we are moving forward to achieve it.
I see. But then, given your experience, would you say that it is possible for AI data centers or AI factories that are being planned right now for them to be actually really sustainable, or if there is some kind of a trade-off? What do you see as an expert?
Can be sustainable. As of now, no, but in the future, this will be sustainable. It's not yet. All the data center players and government is doing effort, so this will definitely will success on this.
I see. How about you, Mahendra? Is there a trade-off?
No, so Deborah, you see, so it is definitely sustainable, but not in a very short or near future. It will be a long-term story, and long-term efforts to be made from every organization and every government ecosystem as well, because it doesn't any industry cannot be made sustainable with the single effort. It's a two-way road, and the government also have to support, the statutory bodies also have to support, and the ecosystem of the power industry also has to support, like open access is another policy, which is a very good solution to get the PPAs and get the renewable energy injected to the grid. And definitely there are good initiatives happening from government side. The incorporation of IRIDA as an organization, which is a renewable source company. Solar Corporation of India is doing so many projects across the Indian continent, and they are developing multiple solar parks from government perspective. And big names are also developing multiple projects to make sure that the demands and the supply is being rightly balanced. And I think so those are the initiatives definitely will be driving toward the right side. And in not very near, but definitely there will be a time in next decade or so, we will be claiming to be that, yeah, not 100%, but some portion and some campuses are 100% sustainable and having the same demand or same supply of the renewable energy what my one campus is required. So I think though that is a good potential provisioning we can make, or every industry can make, and definitely we can work on towards that. It can be sustainable.
Perfect. My final question to you, gentlemen. We have heat management challenges here in India, which are very different from heat management challenges in, say, colder climates, temperate climates, or in the desert regions of, say, the Middle East. Heat management is quite challenging, and that's where we have been seeing this interesting liquid cooling technology that is gaining a lot of interest. I want to know from you, how bullish are you on liquid cooling? How much does it excite you? And have you made it an active part of your thought process when you're designing and building new data centers?
Yes, we are much excited. As the industry is growing, it is growing vertically. We started from 2 kilowatt, now we reach up to 60 kilowatt in the air-cooled system. What we are doing in the air-cooled system or any kind of cooling system, we are just dissipating, bring the heat from the data center or equipments, putting this to the environment outside by using chiller and all. So when and in this system, our efficiency is going around 1.5 or 1.6. It is depend on the geographical conditions. When we are going for the liquid cooling or DLC, this efficiency of data center will come down 1.05 to 1.2. So we will save a lot of energy. Yeah. We will save a lot of energy because of this liquid cooling or DLC. And other things like we are using refrigerating gas and all, these things will be avoided. This can be done simply with the dry coolers or sometimes mist coolers. We are going in the right direction, and now we have multiple agencies involved in this, doing their R&D. So future is for going for the DLC and liquid immersion cooling, especially for the high dense data centers. But air cooling will not go out because some of the data center component need air cooling also. Let's say most of the servers can be converted into the liquid DLC or into liquid immersion cooling, but switches and we can say storage, they need air cooled system. So this hybrid cooling system will be implemented in the future, or some of the places it is already started. It may be ratio of 70-30, but it will be implemented. This is the future for the data centers.
I see. How about you, Mahendra? How bullish are you on liquid cooling?
Definitely, it's a area, or it's a solution where everyone has to be bullish, and specifically our industry, because it's a I can say the racks are bread and butter of the this industry, and definitely if the rack density is increasing, we have to have the right solution in place. And the last point, which Mr. Kuntal has just mentioned rightly, that hybrid solution, because whenever any new technology is coming in, it doesn't implement it rapidly. It has their own life cycle to implement it. So definitely there are new age ships or new servers which are coming in, definitely will be implementing with the direct to liquid cooling or direct immersion coolings, but that also have their own ecosystem. They also have their own time to manufacture, their own time to deliver and install and test it. So until that comes in the scale, we have to see that all the data centers might has to run on the hybrid solution, wherein my normal air cooled system will be there, as well as there will be CDUs installed for those kind of specific needs or specific racks where the densities are going beyond 50-60 kilowatt per rack or crossing 100 kilowatt per rack. But definitely these hybrid solution will be a near future for next 5 to 7 years, I can say.
Perfect. Thank you so much for that. Now we've come to the very end of the show. I'd like Sanjay to take 2 minutes to make closing remarks. In summary, what would you like to say about building infrastructure for tomorrow, digital infrastructure for tomorrow? Sanjay, what would you like to say? 2 minutes to you first.
Infrastructure for tomorrow going very bright. We are going with the new technology for the construction like PEB and prefab structure. In the power quality, we are increasing like anything. Earlier, we are planning for 10 kilowatt. Now we are going for 60 kilowatt or 100 kilowatt racks. And cooling technology, we are evolving this DLC, liquid immersion cooling, air cooling is up to certain limit. So, because that future is, you can say, going very, changing very fast. And in that AI area, you can say that servers are changing very fast. So that is also pushing all the engineering and design teams to come along and upgrade their systems. And definitely that sustainability and going green is a big challenge because data centers are the energy eater. So we should not leave these things in our design. This is the main criteria, and government is also incentivized for using green energy and sustainability. So that is my overall things. We are going in the right direction.
First of all, thank you so much, Deborah, Atira, for setting up this, and it's a very good discussion. And thank you for my counterpart today, Mr. Kuntal, very well party to with the industry, and he's a very reputed contributor into the industry in design and delivery. So, like he said, the data center delivery and the strategy is definitely bright for the industry, region, and the world with the new edge coming in, specifically AI and machine learning workloads. But I can also touch base on it's a very bright industry. It is going to be huge. If I can talk about for India, we are a vast economy. We are a vast, large population who is driving 40% on the digital side, and now we are moving more towards 50% usage of the digital work front, especially from daily usage of phone, daily usage of digital payments, or these virtual meetings and XYZ. So many things coming in, and maybe there are new tools and new technologies coming in for the youth, for school and college and multiple things. So we are a vast economy, and definitely for building the right strategy from data center design delivery, considering this new edge AI or machine learning or the new technologies, we have to see one thing, right, that what our customers are looking for. We have to decode that what they are currently looking at. what they want in near term, what they want in long term, and what is the trend, which side, what technologies they are currently eyeing. We have to look very closely, and according to those specifications or requirements, we have to design and we have to deliver. And definitely we are on the right path. Like every other part of the world, every industry, or every co-location or hyperscale is eyeing for the liquid cooling or the immersion cooling. Definitely that's a future. And to take a one step further and at least have a strategy ready to adapt faster in this region, because India region, or specifically Southeast Asia and Middle East, these are the very specific regions where the heat generation from the natural sunlight and the local geographical factor is huge. And what I say is, considering the climatic advantage or disadvantage both per se, but definitely for our industry that is an advantage. And we will be getting a good amount of pie from the entire capacities in terms of AI and ML. And definitely the liquid cooling and the immersion cooling will be a game changer for this region. And definitely we have to have ready from our design, from our delivery, and the entire strategy, including the skill sets. And we have to build the new skill sets also in the interim, so that we can be ready with the new engineers to take up those to the next step.
Perfect. Thank you so much, gentlemen. That brings us to the end of this discussion. Building tomorrow's infrastructure, data center design and delivery in the age of AI. Thank you so much, Sanjay Kuntal, Senior Vice President, Data Center Projects, Yotta Data Services, and Mr. Mahendra Choubey, AVP Project and Delivery, STT, GDC India. Thank you so much for joining us. Before we go away, I'd like to remind our viewers that on November 7th, we are coming back with the Mumbai Cloud and Data Center Convention 2025 and the South Asia Awards. Our award nominations are still open. The deadline is July 31. So quickly go to our website and register your team, nominate your team for the awards. We'd like to see as many of you as we can at the Mumbai Cloud and Data Center Convention. With that, it's bye for now. I will see you in 2 weeks with our next episode. Thank you so much for joining us today. I'm Deborah. Bye-bye.